Hey guys, Miss Shelly here. All right, we're back with lesson 3. Today we're going to talk about using linear models to make predictions. This is so cool of a lesson to me because I love that we can use these scatter plots to make predictions about current or future trends. So you can look, say you own an ice cream shop, you can kind of look at your current trend and see, okay, well, if the weather's, it's like what, 80 something out today, how much ice cream am I selling? Well, today wouldn't be a good model because of everything that's going around in the world. We're not really out getting ice cream, but we could look at what our last year trend was, and maybe we can even predict for next year. Maybe we need to have more employees in May or April work than we need to have in February. So we can use our scatter plots to find trends to help us solve problems. So let's take a look at how do I do this. So there's a couple things that we're going to do. The first thing is we need to draw our trend line. Now remember, trend lines can be tricky because they're going to be a little off depending on how you draw them. I will tell you that in your work you're going to do today, all of the trend lines are already drawn for you. Okay, I just wanted to give you one example of drawing a trend line. So I'm going to do the best I can to draw this trend line. Hopefully I can make it good and make it work. Oh, I'm going all over the place. Okay. Remember, you're going to get, you can see here, I kind of deviated just a little bit right after 30. That's fine. It's going to happen. All right, so I drew my trend line. Now I need to find my slope. Remember, in order to find my slope, I need to find 2 dots on this trend line. Now, I have a great dot right here at 80.56. Let's see. So I don't quite pass perfectly through this dot, but it's so close, I'm going to go ahead and use that one. So we're going to use 40.32. Remember, it's not always going to be perfect, and that's okay. So I need to find slope. I'm not going to do rise over run. Instead, I am actually going to do, just so we can remember and practice, y2 minus y1 over x2 minus x1. After I solve for this, then we'll see if my rise over run would have worked. Okay, so my first one is going to be my x1 and my y1, and my second 80.56 is going to be my x2, y2. So just like before, we're going to plug our numbers in. Y2 is 56, y1 is 32, minus x2, which is 80, and x1, which is 40. So 56 minus 32, I'm going to come down here and put 24. 80 minus 40 is 40. So now, is 24 over 40 in simplest form? It is not. So I need to simplify. What number goes evenly into both 24 and 40? 8. So I'm going to divide both my numerator and my denominator by 8. 24 divided by 8 is 3. 40 divided by 8 is 5. Now, why did I go through this when I could just come over here and clearly see that 1, 2, 3, my rise is 3 and my run is 1, 2, 3, 4. See? That's why. Because doing your midpoint formula like we're doing here, our rise over run formula, not midpoint, doing our rise over run, this formula, is making sure that we get the best answer, okay? The right answer. Sometimes rise over run isn't going to work, and in this case, it doesn't work because, remember, this dot right here, this 40.32, isn't perfectly on my line, okay? So therefore, I'm not going to be able to use rise over run. I have to use my formula. Now, after I find my slope, which is 3/5, now I need to find my y-intercept. Remember, the y-intercept is where the line crosses, my slope crosses the y-axis. And lucky for us, it crosses right here at 8. So my y-intercept is 8. Now I want to take my slope and my y-intercept and put it in my slope-intercept formula. So that gives me y equals my slope, which is 3/5, x plus my y-intercept, which is 8. So I talked about how we can use trend lines and scatter plots to solve problems. That's exactly what we're going to do here. We're going to use our equation, our slope-intercept form equation, to solve this problem. The problem is, how many smoothies will we sell if the temperature is 120? As you can see, my graph stops at 100. I can't accurately predict how many I'm going to sell. However, just by plotting. However, what I can do though is I can plug my numbers into my formula to find out. So down here is temperature. That means temperature is X and my Y is smoothies purchased. So therefore, I can take my temperature, 120, and plug it into my slope-intercept formula. So that gives me Y equals 3/5. Now my new X is actually going to be 120 plus 8. So 3/5 times 120 actually gives me 72. It is okay, guys, for this lesson if you use a calculator. If you have a calculator, use it. It's totally okay. Plus 8. And 72 plus 8 equals 80. So when the temperature is 120, I should sell about 80 smoothies. Or actually, it's in thousands. So I would actually sell 80,000 smoothies. 80,000 smoothies, because it says in thousand. So instead of this 40 being 40,000 and 32,000, we just shortened it. But your final answer still does need to represent the thousands. Okay, so now let's take what we've learned here and let's work on some more problems. So it says this graph shows a family's grocery expenses based on the number of children in the family. Using the slope, which it gives us the whole formula, predict the difference in the amount spent on groceries between a family of 5 children and a family of 2 children. Now, that does not mean I can subtract 5 minus 2 and get 3 and do 3. No, it wants the difference between how much does it cost me total for 5 and how much does it cost me total for 2. So I need to take, since the number of children is X, I can take my 5 and my 2 and I can plug them right into my X. And that's what I'm going to do. So I know that my slope-intercept formula is Y equals 21.08. Now instead of X, I'm going to start with 5 plus 85.15. Like I said, guys, it is totally okay if you use your calculators for this lesson. 21.05 times 5 is 105.4 plus 85.1. And then that gives us a final answer of 190.55. So now I need to do the same thing, but this time instead of 5 children, I need to see how much does it cost to feed 2 children. So I'm going to do the same exact thing, except this time I'm going to do it in green. Y equals 21.08. This time my X is going to be 2 plus 85.15. So that gives me 21.08 times 2 is 42.16 plus 85.15. That 5 went weird on me. Now all I need to do is add them up. So my Y equals 127.31. Now, the question wants to know, predict the difference. Anyone remember what operation difference means? Hopefully you just told yourself it means subtraction. And it does. So I'm going to subtract 190.55 from 127.31. Drop that decimal down. 5 minus 1 is 4. 5 minus 3 is 2. I can't do 0 minus 7, so I'm going to borrow from the 8. 10 minus 7 is 3, and 8 minus 2 is 6. So it takes roughly $63.24 is the difference between what a family of 5 children pay for groceries a week and what a family of 2 children pay for groceries a week. So it's not that bad, guys. Pretty easy, pretty simple. Let's go ahead and take a look at another. We're going to look at the same family, okay? It says the graph shows a family's grocery expenses based on the number of children in the family, just like last problem. How many children can you predict a family has if the amount spent on groceries per week is $169.47? Okay, now, can we just look at this graph and come up with an answer? Possibly, but it could honestly be 3 different answers. Therefore, we got to do the math. Okay? So, remember in the last slide, we talked about how number of children is our x because it's on the x-axis, and the amount spent on groceries is y because it's on the y-axis. So now, instead of finding out the number of children they have, I want to know, well, how many children do they have? But this time, I know the total they spent on groceries. Since the amount spent on groceries is y, and I know that they spent $169.47, I'm going to plug that $169.47 in for my y. So that's going to look like 169.47 equals 21.08x plus 85.15. And that's because this time I'm looking for x. I'm looking for the number of children. So I have a 2-step equation. Remember, we're going to ask ourselves, all right, what's happening to my x? Well, I'm multiplying 21.08 and I'm adding 85.15. So I need to do the opposite, work backwards. So the opposite of adding 85 plus 15, subtracting 85 plus 15. That cancels out, and that leaves me with 21.08x on this side. And I need to now subtract 85.15 on this side. When you subtract that, you'll get an answer of 84.32. So I've subtracted. Now I'm multiplying, so I need to do the opposite, which is dividing. So I'm going to divide 21.08 on both sides. 21.08 divided by 21.08 cancels out, leaves me with 1x or x. And if I use my calculator and divide 84.32 by 21.08, I will get an answer of 4. So how many children can you predict a family has if they spent $169.47 per week for groceries? They would have 4 chillins. 4 chillins. All right, good job, guys. So let's move on and look at some more problems. So now it says the scatter plot shows the number of people at a fair based on the outside temperature. Because I don't know about you, but I'm not going if it's hot. How many fewer people would be predicted to be at the fair on 100 degrees Fahrenheit than on a 75 degree Fahrenheit day? I know who one person is not going to be at the fair on a 100 degree day. That's me. A 75? Yeah, I'd probably be there. 100? No, thank you. So what I need to do now is going back to that first slide. We talked about our steps. The first thing is my trend line. Well, that's already drawn, so I'm good there. The second thing, though, is I need to find my slope. What is the slope of my line? So I need to find 2 dots that are kind of super close to the line, but also are going to be kind of easy for me to work with. If I look about here at 75, I can go from 75 and I can go up to about 10. So 75, that kind of gets me right there on that line. Oh wait, that's 70. I'm sorry, guys. 75, 10. That's right about there. I was like, wait, that line's off. So I can use 75, 10. Remember, when you're trying to find your points that are on the line, try and pick points that are going to be easy to work with. All right, so if I look here, it looks like I have one that's right on this line. So right on my 6 for my y, but then it looks like, I'm going to say that's more 99. We'll just estimate 99. All right, so now that I've done that, I can find my slope. I'm going to use my formula, of course. Y2 minus y1 over x2 minus x1. So let's label. We're going to make these my 1s. We'll make these my 2s. I'm getting really good at trying to make sure my y's look like y's and not x's. Y'all yelled at me so much. So that would be 6 minus 10 over 99 minus 75. 6 minus 10, that's a small number minus a big number. So that is actually going to give me negative 4. 99 minus 75 gives me 24. All right. Now, for this, I really prefer to deal with decimals. I like decimal operations. So I am going to divide 24 into negative 4. When I divide that, it's going to give me negative 0.16. I would rather work with that than work with fractions and having to multiply and then subtract or finding common denominators. So for me, this is much easier. Okay, so it says what this negative 0.16 means is that every degree that goes up, the amount that people come, go down by negative 0.16. Okay, so now that I know what my slope is and I know how to operate it, first I need to figure out, okay, so I want to see how many fewer people are going to come if it's 100 than if it's 75. Since I want to see that difference, I'm actually going to go ahead and subtract to find my change in temperature. So my temperature 100 minus 75, which equals 25. That 25 is my change in temperature. So now I can plug that in. I can do just my slope, which is y equals negative 0.16 times my change in temperature, my x, 25. I don't need my y-intercept because I don't have my y-intercept on this time. So I'm only using the condensed slope formula. So y equals mx. Okay, so I just need to multiply now. Negative 0.16 times 25 gives me y equals negative 4. Now, remember, the number of people are in thousands. So my final answer is negative 4,000. And that's it, guys. So all we're doing for this is we're plugging our numbers into our formulas that we already know. All right, sometimes they're going to go ahead and give us the formula. Sometimes we're going to need to find that slope ourselves. So let's take a look at another example. If x represents the number of years since 2000, so 0 means 2000, the 2 for years, this 2 for years, that really is 2002. So that's how it's working. Y is going to represent the gas price. Predict the difference between the gas prices in 2013, which we don't know, and 2001, which we also don't know. So in order to figure out what gas was like in 2013 and what gas was like in 2001, we need to figure out what's the slope of my line. So I'm going to pick, again, 2 dots that represent. Now right here, you can see I have this 4, 2. That's a great one. The line goes through it pretty close. Not perfect again, but it's right there on it. And then I also have another pretty good one right here at 13. Oh, sorry, not 13. That's 11. Ooh. 11. And we'll say that this is 11 and this is 5. We'll give this one, that looks like 5.8. So now that we have this, we need to find our slope. So once again, I need to label. I'm going to make this y or x1, y1, x2, 2y2, and I'm going to plug them into my formula. y2 minus y1 over x2 minus x1. So I'm going to plug my numbers in. I have 8 minus 2 over, oh, sorry, that's 5.8. 5.8 minus 2 over 11 minus 4. So if I use my calculator again, I could do 5.8 minus 2, and that's going to give me 3.8 over 11 minus 4, which is going to give me 7. So once again, when I'm doing this problem, I need to, I'm going to divide, okay? I want a decimal, so I'm going to do 3.8 divided by 7, which is going to give me 0.542857. We're just going to say 0.54. Now what I'm going to do is I can take that. So now I know that y equals 0.54x. So now I can put any of these numbers in for x, and I can figure out what it's going to be. So I need to know 2013. That's 13 years after 2000. So I'm going to do y equals 0.54 times 13. So 0.54 times 13 gives me 7.02. And now I can do y equals 0.54 times 1. And that gives me 0.54. And now I just need to subtract 7.02 minus 0.54. And that's going to give me an answer of 6.48. All right, guys. Good job. Oh, wait. You know what? Michelle, I just realized she messed up. She did. Look right here. I said that I said that 5 was in between 2 and 4. Man, don't you hate when the teacher messes up? I sure do. So, I just need to redo this right here. This one's wrong. And then redo this. It's okay, guys, that we mess up. We're going to do this. Remember, math's about messing up, making mistakes. But when you see an answer that's like, whoa, that's a lot of money, kind of stop and think about it. So that's not 5.8. That is actually, should be 3.8. It's okay to make mistakes. Even your teachers make mistakes. So 3.8 minus 2, which sounds a lot better, which gives me 1.8. So now if I divide 1.8 by 7, I get 0.257142857. That's way too many. Let's just say it's 2.257. So now my slope is y equals 0.257x. Now we want to plug in 2013 and 2001. So let's go ahead and start with 2013. So that's going to be y equals 0.257 times 13, which if I do 0.257 times 13 on my calculator, because we all love our calculator, we get y equals 3.341. Now let's do 2001. So that's y equals 0.257 times 1, because that's 1 year after 2000. So you see how that works? Y equals 0.257. So now to get my final answer, I need to subtract. So 3.341 minus 0.257. Now, my final answer, the difference in gas prices between 2013 and 2001 is, drumroll please, 3.08. That is correct. All right, guys, remember, it's okay to make mistakes, but it's not okay to give up. Okay, I realized I made a mistake. I realized that $6 was way too much money. So I stopped, I re looked at my problem, I figured out where I went wrong, and I corrected it. That's totally okay. We're going to do that. As a math teacher, it's totally okay that I do that. So don't worry if you do it, okay? So let's take a look at our very last problem. The scatter plot shows a hiker's elevation above sea level over time. The equation of the trend line shown is, I love it when they give us the equation, y equals 8.77x plus 686. To the nearest whole number, make sure we remember nearest whole number, predict what the hiker's elevation will be after 145 minutes. All right, first let's remember, let's look at our graph. Time is our x, elevation is our y. It's asking us to find what something's going to be in time. So that means we just have to plug our 145 minutes in for our x because x equals time in this problem. So I have y equals 8.77. Remember, instead of x, I'm going to put my time, which is 145 minutes, plus 686. So 8.77 times 145 is 1,271.65 plus 686. Now I just got to add 1,271.65 plus 686 is 1,957.65. Remember when I told you to remember that to the nearest whole number? Right now. So if we put this as our final answer, we would get points taken off because it's not a whole number. By the way, that's 6.5. Not that it matters that much, but so I need to change it to the nearest whole number. So I'm going to look at my 10th place. If it is higher than 5, I go up. If it's 5 lower than 5, I stay put. So it's 6, it's higher than 5. So that means that the hiker's elevation after 145 minutes would be 1,958 feet. And that's all you have to do. All right, guys, go on, hop on over to Teams and start working on today's assignment. Remember, if you have any questions during this, please send me a message, okay, guys? I'm always here for you. Talk to you. Oh, remember,